Okay, so we are going to go over lesson 69-610, part 1. Typo, I forgot to write that in there. Might be, everybody. First video here, we're going to go over how to solve equations that have logarithms in them. But before we do that, I do want to go over just a quick kind of recall of what we've done here before. So simplify the following. Be a good idea if you guys pause this, try this on your own. Okay, hopefully you guys have paused it, given yourself a shot here. Things we need to remember if we are going to be looking to cancel things, we have to have the same base. So if this is a log base 5, I've got to make sure that I have a log base 5 of 5 to some power. Okay, I've got to be able to plug something in. If these two bases are the same, that's going to be that's what's going to allow us to cancel. Okay. So 5 to what power is the same thing as 125? Well, 5 squared would be 25. 5 cubed would be 125. Okay, so I basically just take that 125, rewrite it as 5 cubed. Now their bases match, so I can cancel, and my answer is just 3. Okay, I've got a log of 10. Remember, if it's ever just a log, then that means that it is a log base 10 of 10. Okay, so our two bases here match, so we're ready to cancel. I could get rid of this, I could get rid of this, but what do I have left? Well, if it's just a 10, remember that's a 10 to the first power, so our answer for this one is 1. Okay, now, these two examples we haven't seen as much. We talked about them super briefly in lesson 6.4 part 2. But again, I have an exponential function here. This is 6 to some power. And I have a logarithm, log base 6 of something. Okay, so that's just another way that you can see an exponential function and a logarithm together. Do their bases match? Yes, their bases do match. So that means that we can cancel. And what am I left with for my answer? Well, my answer would be 12. Okay. Left one over here, we've got an e to the ln. Remember, if you guys see an ln of x, that is essentially a log base e of x. So ln is a base e, e obviously is a base e. So again, those two would cancel. And then what am I left with? Well, I am left with just my x. Okay. So we are going to be using this bases matching, allowing us to cancel, bases matching, allowing us to cancel. And we're going to have to use that to be able to solve equations that have logarithms. And we're also going to have to use it to solve equations that have exponents, or x's up in the exponents, to be more exact. Okay? So starting out with, we'll start with solving logarithmic equations. I have 2 equals log base 3 of x plus 12. Or x plus 2, sorry. The first thing that we have to do is we have to isolate your logarithm. Okay? And that just means you have to get the logarithm by itself. So I've got a log base 3 of x plus 2. Just to clarify, this is a logarithm that is by itself. Okay? If we had a log base 3 of x plus 2 plus 4, now this logarithm isn't by itself because it's got this plus 4. So to isolate it, I would have to subtract that 4 to the other side. Okay? So just to clarify, this one here is already isolated. Now, we've got a new word here. Your second step is going to be to exponentiate. Exponentiating is something that is brand new, but I know that I need to exponentiate because we need to use an exponential function to get rid of this logarithm. Okay? Now, what does the base of that exponential function need to be? Well, hopefully you guys can look at this logarithm and say, hey, that's got a log base 3. So if I want to cancel that logarithm, my exponential function is going to need to be a 3 for its base. So I am going to exponentiate. So what does exponentiating look like? Well, you know, if you had a 3x equals 2, we would divide by 3 because those are inverses, right? So we show that we divide by 3 and cancel. So if I'm going to exponentiate with a base of 3, this is something that is brand new, and you might need to have these videos up while you're doing this. So to exponentiate, I am going to write down a 3, and that is going to be the base of my exponential function. And then I'm going to take this log base 3 of x plus 2, and I am going to move that up into the exponent. Okay? And that is our exponentiating step. So I take a base of 3. How did I come up with this 3? Well, because that's the base of that logarithm. Okay? And I took this log base 3 of x plus 2, and I have now moved this up into the exponent. Okay? Now, we are solving equations. And if you do something to one side of the equation, you must do the same thing to the other side. So I also need to exponentiate on the left side, which means I have to have a 3 because these two things have to match. And then where is this 2 going to go? Well, that 2 is also going to move up into the exponent. Okay? Now, the whole point of this exponentiating step is we are trying to get rid of our logarithm, which if I look here, I've got a base 3 and a base 3. I can cancel that and this logarithm. And when I do that, my x plus 2 just moves down. Okay? Just like we did on this last slide here. I had a 6 to the log base 6 of 12. These two things canceled each other, and I was left with just a 12 for my answer. So I've got a 3 to the log base 3. These two things cancel, and I am left with just an x plus 2. Now, x plus 2 equals 3 squared. Well, what is 3 squared? Well, 3 squared is 3 times 3, which is 9. The last thing I need to do is just solve this remaining equation. So I'm just solving for x, trying to get x by itself. So I would subtract by 2, and I've got to do that on both sides. And that ends up giving me that 7 equals x. And that is my answer. Let's do another example over here. I've got a 3 equals log base 6 of 2x minus 8. Again, I've got to make sure this logarithm is by itself. And it is. There's no extra like plus 2 or something over there. Okay? So I need to exponentiate. What does the base need to be when I exponentiate? Well, that's a base of 6 there. So we're going to need to exponentiate with a 6. That log base 6 of 2x minus 8, exponentiating means it moves up into the exponent. So I have to do the same thing on the other side, which means I'm going to have a 6, and then that 3 moves up in the exponent over here. Okay, so this is my exponentiating step. How did I know to use that 6? Because there's a base of 6 in that logarithm. Now we are going to look to cancel. When I do that, I'm left with a 2x minus 8. And then on the left side, I have this 6 cubed. What is 6 cubed going to give me? Well, it's 36 times 6. And 36 and 6 gives me 6. 36 and 6 and 3 is 180. So 6. 216. So this gives me 216. So now that I've exponentiated, and I got rid of that there, now it's just solving a normal equation. So the first thing I would want to do would be to add 8 to both sides. That gives me 224 equals 2x. Divide both sides by 2. And I get 112 equals x for my answer. Okay. We got one more here. Might want to pause the video, try it on your own. I will say there is kind of a little trick with this one, so you might just want to stay and listen. Okay. Again, I need to exponentiate. What does the base need to be when I exponentiate this? Well, if I'm looking at that log, I see it's a log base 9. So I need to have a 9. And then that logarithm, that log base 9 of 3x minus 1 moves up to the top. Okay. Whatever I do to one side of the equation, I have to do the same over here. So I'm going to need to exponentiate over here as well. That is going to be a 9 to the 1/2 power. Okay. So again, over here, this side is going to cancel just like I want it to. It leaves me with a 3x minus 1. Now on the left side over here, some of us might get a little bit confused. 9 to the 1/2 power. Remember our jam rule? So if something is written as a fraction, it's actually a square root, and it's the square root of 9. So what is the square root of 9? Well, it would be 3. So then I would add 1 over 4 equals 3x divided by 3, and I get that x equals 4/3. And those are 3 examples there of solving logarithmic equations. Again, things to pay attention to. We're going to exponentiate. That's something brand new. Okay, it's going to be confusing at first. Log base 3, I got to have a 3 there so they will cancel. Log base 6, I got to have a 6 there so they will cancel. Log base 9, I got to have a 9 there so they will cancel. So that's the most important thing, the exponentiating step and knowing how to show that.